Our next summation rule is about splitting a sum into two. Again, let's see this on an example. Let n be a non-negative integer. Compute or simplify this following sum. The sum of the remainders upon division by 2 of the first two n non-negative integers. What's the simplest idea? What's the simplest way to approach this? Well, these remainders, they go like 0, 1, 0, 1, 0, 1, and so on. So every addend here is a 0 and a 1. Thus, logically, we should be able to separate the zeros from the ones. So let's do it. First of all, we restate this in terms of the set. And now we can split the sum into two bunches. One bunch with the even s's. So this notation means we restrict the sum only to those s's that are even. And then, of course, the others, which are the odd s's. If s is even, then s remainder 2 is just 0. And if s is odd, then it's 1. So the first bunch is just a sum of zeros, and the other bunch is a sum of ones. The sum of zeros is 0, so it basically goes away. Remains to simplify the ones. As we know, a sum with equal addends is just the sum times the addend, the number times the addend. So this sum of ones is the number of all odd elements of the set times 1. Okay, times 1 we can just throw away. What's the number of odd elements in the set? I claim that it's n, because the odd elements of 0, 1, 2, and so on, n minus 2, and minus 1 are 1, 3, 5, and so on, 2, and minus 1. And there is n of them. So what have we learned and what have we used? We have used the notation sum over all elements that satisfy a certain statement, where S is a finite set and A of S is a logical statement for each S and S. And this notation basically means the sum of over all S's that satisfies the statement, or formally speaking, the sum over all elements of T in S that satisfy A of T. And we have furthermore used the formula that if you want to sum over all elements of a set, and you have a logical statement, you can split the sum into those S's that satisfy the statement and those S's that don't. So here is the ones that satisfy it, and here is the ones that don't. And another way to say it is the following. If S is a finite set, and if a finite set S is decomposed into two disjoint subsets X and Y, and by decomposed, I mean their union is S, and by disjoint, I mean their intersection is empty, then the sum over all elements of S equals the sum over all elements of X plus the sum over all elements of Y. This is a way of splitting a sum into two pieces.